Welcome to Classwork 7.5, Textbook Section 5.5. Today we're going to talk about solving trig equations. So let's get right to example 1. The first thing you have to do is highlight this find all solutions. Notice how there are no restrictions anywhere. So this means like all possible answers here. So let's keep that in mind as we're going through the question. So solve the equation 3 sine x minus 2 equals 5 sine x minus 1. Make sure in your mind you think of the sine x as like a box, and we're trying to solve for the box. So let's start by subtracting 3 sine x from both sides. So now we have negative 2 equals 2 sine x minus 1. Now we're going to add 1 to both sides. Negative 1 is 2 sine x. So sine of x must equal negative 1/2. Now think about your circle. Negative 1/2 happens to have these two tick marks. So we're going to write x is equal to 7 pi over 6 and 11 pi over 6. Now the problem with our answer is that that's only two of the answers. We know there are infinite answers if there are no restrictions. So all we do, put a big bracket, and then put plus 2 pi k. And what the 2 pi k means is it's basically adding full rotations or full circles to our answer. So essentially, if you ever see like find all possible answers or find all solutions, just have to add a 2 pi k to your answer, and that covers every possible answer. So now let's look at this tan problem. Notice how this is actually easier because it's already solved for us. Tan is equal to root 3, so that happens at these two tick marks. So we can write x must equal pi over 3, 4 pi over 3, put a big bracket, plus 2 pi k. Now, if you want to be fancy, you can actually combine it. Notice how these answers, they're exactly 180 apart. So we actually could simplify it to say pi over 3 plus pi k. And you can always do that if the answers line up nicely, and for tangent, they often do. But either of those is perfectly fine. Okay, so let's box that. Either of these is fine for the answer. And then I'll also box this one. And let's go to the next example. So quickly notice that this one does have a restriction. So we're not going to have to do this plus 2 pi k thing we did last time. But there is a difference here. Also notice there's a 3x. So to handle this, we're going to have to actually draw 3 circles. So we're going to draw circle 1, circle 2, circle 3. And you're going to mark everywhere that tangent hits 1. So I'll do that in red for you. That's going to be at these places here. Now the reason this picture is helpful because that tells you there are actually 6 possible answers here. So now what we're going to do, grab this 3x right there because we're solving for the 3x first to make it easier. And we're going to write what those answers would be. So the first one was pi over 4, and the next one is 5 pi over 4. Now I'm going to work vertically to make it a little bit easier to see. To get the next ones, let's just add 2 pi. So imagine you add one rotation. That's going to be 9 pi over 4 and 13 pi over 4. And again, the way we do that is we're just adding 2 pi. Now notice there's a third rotation, so you got to add 2 pi again to these. So add 2 pi, you get 17 pi over 4, and then you get 21 pi over 4. Okay, now of course you're probably thinking, how could these be the answers? Because clearly we said earlier, it must be between 0 and 2 pi, and these answers are not. That's because we solved for 3x. So look at this 3x right here. We got to solve for x. So let's take all these answers, multiply them by 1/3. That will fix everything. X equal to pi over 12, 5 pi over 12, 9 pi over 12, 13 pi over 12, 17 pi over 12, and 21 pi over 12. And notice how all of these are within the range of 0 to 2 pi. That's it. Next example. Notice how it's very similar to the last example. It gives you a range of 0 to 2 pi, which is great. We only got to consider answers in that range. No need the plus 2 pi k. But notice how it's x over 2. So if you look at the last one, if you really look at this 3x right here, we drew 3 circles. So if we go to this thing, look at this x over 2 right here. That means we're going to draw half a circle. Let's mark where sine hits root 3 over 2. That would be here and here. So now same technique. Grab the angle we're working with, x over 2. That's equal to the two angles we just found, which would be pi over 3 and 2 pi over 3. Now be careful because these answers are within the range, but we haven't solved for x. We solved for x over 2, which means simply take all of these, multiply it by 2, and x is actually 2 pi over 3 and 4 pi over 3. And there's our answer. Okay, next one, solving a trig equation quadratic in form. So you could just straight factor this. Some people like to do a u sub, so I'm going to show you that. Let's let u equal cosine x. That will make it 2u squared plus u minus 1. That makes people much more comfortable, so you can do that if you like a u sub. Also, let's notice that there's a 0 to 2 pi restriction, so that makes it easier for us as well. Let's factor this. That's 2u, u, 1, 1, plus and minus. So u should equal 1/2, or negative 1. We're going to plug in our cosine value. So cosine of, not u, cosine of x, that's equal to 1/2 or negative 1. So here's our circle. Where does cosine hit 1/2 or negative 1? So let's just think about it. The 1/2 happens right here, and negative 1 happens here. So x should be pi over 3, 5 pi over 3, and pi. We're going to box that. And we're done. Now, if it had asked for all possible, so if it was all possible answers, to handle that's pretty easy. Just put a bracket around your answers and put plus 2 pi k. So notice how if it were all possible, it's really not a big deal. Just put plus 2 pi k. Now for these last two, we're going to need a calculator, right? So notice how it says calculator. So I'm going to go, here's my calculator. The first thing you want to make sure you do is that make sure you're in function just to make sure it's standard. And make sure you are in radians. So I'm going to do that on mine really quick. So again, top right, make sure you have selected that pi symbol. Now let's go back to our paper here. For solving all these with a calculator, make sure you guys put a big note here, big star. You want your equation, whatever it is, to equal 0. That's huge. Okay, so put a box. Really highlight that. That's important. So I'm going to 3D box that really quick. So for this one, we're going to write cosine x plus 0.4317. That should equal 0. This is the function we're going to graph. Cosine x plus 0.4317. So I'm going to do that over here. Symbol. I've got it ready for us. So I'm going to tap graph it. There it is. Let's find the roots now. So menu root. So I'm going to note 2.017. Function root. 4.266. And the last one, function root, 8.3. So I'll note that, but we actually don't want that one. And I'll talk about that in a little bit. So here was the graph we're looking at. I'm going to notate it really quick. Right there we had 2.02. Right there was 4.27. And this one was 8.3. We deny this one because at the very beginning of the question it said 0 to 2 pi right here. So that's right here we're looking at. That means we want 0 to about 6.28. So 8.3 is clearly bigger, so those are the only answers left. So our answers here are 2.02 and 4.27. Done. Now for the next one, same thing. Let's go back to our calculator. I'm going to graph it. And we're going to find the roots. So function root, 3.807, function root, 5.616, and then just check this one, 10.09, so we clearly don't want that one. So we'll note the first two, and let's head back to our worksheet. So there's my graph. I'm going to notate that this one was 3.81, that one was 5.62, and x must be 3.81, 5.62. That's it. Now, just so you know in the calculator, this thing is a little tricky for your calc. You just have to type sine x squared, and the calculator knows to implicitly put like those brackets there. So if I go back to my calculator, you'll see that on mine. So if you just type that, that's how you get sine squared. Okay, and notice how I actually just graphed it straight. That's because this actually equals 0 at the beginning, so there's no need to do any algebra. That's it.